Hi. So there's some exciting news. At the moment, we are traveling through the tail of Comet Thatcher, and this causes the meteor shower called the Lyrids. So you can look at these in the north direction of the sky in the evening between early hours of the morning, say 2 a.m. and dawn. If you want to look for the constellation Lyra and the star Vega, but the best way to see them in a dark sky at night is just to look generally at the sky and you'll spot the meteors. Up to 10 to 15 every hour, and I think they're much better to view in the northern hemisphere, but we still can see them in the southern hemisphere. And this shower normally runs for another week until around the 26th of April. So I hope you spot some and enjoy. Today I was asked to explain why planets don't fall into the sun or the moon doesn't fall into Earth. Because the sun has such big gravity compared to the planets, and Earth has such a big gravity compared to the moon. So I'm going to use a little bit of physics, and any physicists, apologies for oversimplifying. So essentially, if you picture a stone on a string, imagine you're spinning a stone on a string. There are two main forces that act here. There's the force pulling the stone back towards your hand as you spin it, that's centripetal force, and there's the force that's pulling the stone as you're swinging it away from your hand, and that's called centrifugal force. So very simply, that's what happens with, say, the sun and the earth. The earth is actually going in a circle, well, not a perfect circle, but it's moving really fast around the sun. So it's being pulled in by the gravity of the sun, but the actual motion and speed of the earth traveling around the sun is forcing it away, and these two are balanced, and that's what keeps it in orbit. It's the same for the moon traveling around the earth, and for satellites in the International Space Station. So if you imagine a satellite is going around Earth, it is constantly being pulled into Earth by the gravity, but it's traveling fast enough that it keeps passing just past the point that it would fall. So it's going fast enough to stay in its orbit around the Earth. Something else that's interesting is these forces that are acting and balancing one another create what we call microgravity. So when you see the astronauts on the space station, they actually are still close enough to Earth to feel Earth's gravity, or I think about 90% of it. But because they're in this situation of always falling to Earth but passing, and all these forces are acting on them, the space station, the stuff inside the space station, the astronauts themselves, are all actually experiencing the same gravity in a vacuum, which makes them all fall at the same speed, and it gives the feeling of weightlessness, although it's actually not zero gravity. Hope that wasn't too confusing and that you found it interesting, and let me know if you get to see the meteors. I'm going to keep looking every night. I'm going to be really tired, but I'm going to try to see some. Stay safe.